When I first started as a front-end developer, I thought I knew how browsers work. A server has a website, the browser asks for it, and poof, it appears. Right, like just one big pre-built image. I was completely wrong. The truth is, browsers are doing an insane amount of work behind the scenes. Think about it this way, when you install a mobile app, you wait for it to download, then you wait for it to install. We give it plenty of time. But a browser, it has to do all of that from scratch in the blink of an eye. If it takes more than 2 seconds, we close the tab. The high-speed high-stakes process is what this video is all about. We're going to break down the magic that happens between you typing in a URL and a beautiful website appearing in your screen. Ready to see how it works? Let's go! Okay, so as we said in the intro, a browser's number one job is to render a website as fast as possible. But this creates a dilemma. If the browser tries to render the page before all the resources are downloaded, you get a broken, messy looking site. And this problem is also known as a flash of unstyled content, or FOUC for short. That's a bad user experience. On the other hand, if the browser waits for every single file to download, you could be staring at a blank white screen for way too long, which is another bad user experience. So, how does the browser solve this? This is where it performs its first piece of magic, a technique called progressive rendering. In simple terms, this means render what you have as soon as you can. The browser doesn't need to download everything to get started. That's why you can often see the text and layout of a page appears on the screen, while the images are still loading in. But does the browser start painting pixels the instant it receives the first byte of code from the server? Not quite. Before it can draw anything, it needs a minimum amount of information. It needs the essential blueprint for the page. These minimum required resources are the HTML document itself, any render blocking CSS, which is usually the CSS linked in the head tag, and any render blocking JS linked in the head tag. These resources are called render blocking because the browser literally blocks rendering. It will not paint a single pixel on the screen until it has downloaded and processed them. The series of steps the browser takes to process these essential files and turn them into that initial render is exactly what we call the critical rendering path, or CRP. And that's what we're going to break down next. Alright, we have defined the critical rendering path, or CRP. Now let's break down the exact steps that the browser takes to get the first painting of your website onto the screen. First, the browser starts downloading the HTML file, but that file is just a long string of plain text, characters, and angle brackets. It doesn't have any real structure yet. So the browser's first job is to parse this text and turn it into a structure it can understand. This structure is called the Document Object Model, or DOM. You can think of the DOM as a family tree for your web page. Each HTML tag, like body or heading, becomes a node or branch in that tree. This tree structure is essential because it gives the browser a logical map of the page and allows JavaScript to easily find and manipulate elements later on. As the browser is busy building the DOM tree from your HTML, it might come across a link tag in the head pointing to a CSS style sheet. Just like with the HTML, the CSS file is also just a text file full of rules. So the browser has to parse it and turn it into a similar tree structure called the CSS object model. This tree maps all the styles to corresponding element in the DOM. This CSS is render blocking. The browser will not paint anything on the screen until it has finished downloading and building this CSS object model. Why? Because it needs to know how every element should look before it tries to draw it. It would be inefficient to draw everything and then have to redraw it a millisecond later once the styles arrive. While parsing the HTML, the browser might hit a script tag in the head. If that script tag doesn't have a special attribute, the browser has a big problem. It has to stop everything. This is called parser blocking. The browser literally pauses building the DOM tree. It won't read any more HTML until it has downloaded, parsed, and executed the entire JavaScript file. The reason is that JavaScript has the power to completely change the structure of the page. It can add new elements or remove existing ones. The browser pauses because it doesn't want to waste time building a DOM that the JavaScript might immediately tear down and change. This is a classic reason why a script trying to access a body element from the head fails. The script runs, the HTML parser is paused, and the body element hasn't even been created yet. So how do we fix this? We use the defer attribute in our script tag. When the browser sees the script tag with defer attribute, it does something much smarter. It starts downloading the JavaScript file in the background. Crucially, it doesn't stop parsing the HTML. It continues building the DOM tree without interruption. Only after the entire HTML document has been parsed and the DOM tree is fully built will the browser execute the downloaded script. This is the perfect solution. The page's structure gets built as fast as possible. The script doesn't block anything, and by the time the script finally runs, it has the complete DOM to safely work with. Okay, let's do a quick recap. The browser has parsed the HTML to create the DOM tree, and it's parsed the CSS to create the CSS object model tree. So now we have two separate trees. The browser needs to combine them to figure out what the final page will actually look like. This next step is creating the render tree. You can think of this as a browser's final blueprint. It takes the DOM tree and for each visible node it finds the matching styles from the CSS object model and attaches them. The keyword here is visible. The render tree only includes what will actually be displayed on the page. It completely ignores things like the head tag or any element that has a CSS property of display none. Now that we have the render tree, the browser needs to figure out where everything goes. This is the layout phase. The browser goes through every single node in the render tree and calculates the exact size and position on the screen. It calculates the geometry of the entire page. This phase is also sometimes called reflow, and it can be one of the biggest performance bottlenecks. If you change an element's dimension with JavaScript later, you can force the browser to rerun this entire calculation for the whole page, which can make your site feel sluggish. The final step is the paint phase. Here, the browser takes all the layout information and starts filling in the actual pixels on your screen. To make this process more efficient, the browser often paints different parts of the page onto separate layers. Then, in a final step called compositing, it stacks these layers in the correct order to display the complete web page you see. And that's it. If you found this video helpful, share it with others, give it a like and subscribe. See you in the next video.